Microsoft Research has just released Fara-7B, and this could fundamentally change how we think about AI agents. While the industry has been focused on cloud-based solutions from OpenAI and Anthropic, Microsoft has taken a different approach, one that prioritizes privacy, efficiency, and accessibility. So, what exactly is Fara-7B? It's a 7 billion parameter computer use agent designed to interact with your computer the same way you do. It processes screenshots of your screen, understands what it's looking at, and executes actions through clicks, typing, and scrolling. What makes this particularly noteworthy is its approach. Fara-7B doesn't rely on accessibility trees or complex back-end parsing. It operates purely through visual understanding, mirroring human interaction patterns. The real innovation here lies in its deployment model. Unlike most AI agents that require substantial cloud infrastructure, Fara-7B is designed to run entirely on your device. For enterprises and privacy-conscious users, this represents a significant shift. Your data never leaves your machine, inference happens locally, and you avoid ongoing cloud costs. This isn't just about privacy, it's about creating a fundamentally different architecture for AI assistance. Let's examine the performance data, because the results are quite remarkable. On WebVoyager, a standard benchmark for computer use agents, Fara-7B achieved a 73.5% success rate. To put this in context, when GPT-4o was evaluated as a computer use agent using the set of marks approach, it achieved 65.1%. Fara-7B also surpassed UI-TARS 1.57b, another model in the same parameter class, which scored 66.4%. Beyond raw accuracy, efficiency tells an important story. Fara-7B completes tasks in approximately 16 steps on average, while UI-TARS 1.57b requires roughly 41 steps for comparable tasks. This efficiency translates directly to cost savings. Microsoft estimates an average cost of $0.025 per task for Fara-7B, compared to approximately 30 cents for set-of-marks agents backed by models like GPT-5 and o3. Microsoft also developed WebTail Bench, a new benchmark specifically designed to evaluate practical, real-world tasks that existing tests don't adequately cover. On this benchmark, Fara-7B scored 38.4%, while GPT-4o achieved 30%. These tasks include activities like booking travel, filling out forms, and managing accounts, the kind of multi-step workflows that consume significant time in daily operations. The training methodology behind Fara-7B is particularly sophisticated. Microsoft developed Fara-Gen, a synthetic data generation pipeline built on their Magentic-UI multi-agent framework. Rather than relying solely on scraped web interactions, the system generates tasks from real web pages, attempts to solve them using multiple AI agents, and then verifies success before incorporating the data into training. This process produced 145,000 verified task trajectories containing over 1 million individual steps across 70,000 plus domains. The base model is Qwen 2.5 VL7B, which Microsoft fine-tuned exclusively through supervised learning. No reinforcement learning was applied. The fact that these results were achieved without reinforcement learning suggests substantial room for future improvement. For enterprise adoption, data security is paramount. Yash Lara, Senior PM Lead at Microsoft Research, described this as pixel sovereignty. All visual processing and reasoning occurs on-device, helping organizations meet strict regulatory requirements, including HIPAA and GLBA. Microsoft has implemented several safety mechanisms. Every action Fara-7B takes is logged for complete auditability. The model is designed to operate in sandboxed environments where users maintain full monitoring and control. Perhaps most importantly, Fara-7B recognizes critical points, situations requiring user consent before irreversible actions like sending emails or completing financial transactions. In safety testing, the model achieved an 82% refusal rate for harmful requests. The release strategy is notably open. Fara-7B is available under an MIT license through Hugging Face and Microsoft Foundry. Microsoft has also released a quantized version optimized for NPU acceleration on Copilot Plus PCs running Windows 11. For developers, this is accessible through the AI Toolkit in Visual Studio Code. This open approach has strategic implications. Researchers can fine-tune the model for specific domains. Developers can build applications without cloud dependencies. Organizations can deploy AI agents for sensitive workflows while maintaining data sovereignty. This creates an ecosystem that extends beyond Microsoft's direct control. We should acknowledge the limitations. Fara-7B shares challenges common to language models. It can make mistakes on complex multi-step tasks, occasionally misinterpret instructions, and may hallucinate or take incorrect actions. The pixel-based approach, while flexible, can be fragile. UI changes in applications may cause unexpected behavior. Microsoft is transparent about these limitations and emphasizes that this is an experimental release. The broader context matters here. We're witnessing rapid development in agentic AI. OpenAI launched Operator. Anthropic has Claude's computer use capabilities. Google is undoubtedly developing similar tools. But most of these implementations are cloud-centric. As Charlie Dye, VP and Principal Analyst at Forrester, noted, Fara-7B signals a gradual decentralization of AI workloads, lowering dependency on hyperscale infrastructure while demanding new strategies for edge governance and model lifecycle management. This represents a meaningful divergence in architectural philosophy. Cloud-based agents offer advantages in raw capability and easier updates. Local agents offer privacy, lower latency, and eliminate ongoing operational costs. For many enterprise use cases, particularly those involving sensitive data or requiring air-gapped environments, the local approach may prove more practical. Microsoft is explicitly framing this as a research preview and community learning opportunity. They're seeking feedback, use cases, and contributions. The fact that this is released openly rather than as a proprietary service suggests Microsoft sees value in ecosystem development and collaborative improvement. For developers and researchers working with AI agents, Fara-7B lowers the barrier to entry considerably. For organizations evaluating agentic AI adoption, it presents a viable alternative to cloud-dependent solutions. For the broader AI community, it demonstrates that smaller, specialized models can compete with much larger systems when properly trained and deployed. The trajectory here is clear. We're moving toward hybrid AI architectures, where local agents handle privacy-sensitive, latency-critical tasks, while cloud systems provide broader reasoning and scale. Fara-7B is an important proof point that this architecture is not only feasible, but can deliver competitive performance today. Web automation has long been characterized by fragility, scripts that break with website updates, APIs with limited scope, and tedious manual processes. Fara-7B doesn't solve all these problems, but it represents genuine progress toward more robust, adaptable automation that operates closer to how humans interact with computers. This isn't vaporware or a distant vision. It's a model you can download, run on appropriate hardware, and integrate into applications today. That tangible availability makes Fara-7B particularly significant in an industry often characterized by ambitious announcements that take years to materialize. As this technology evolves, the questions shift from "Can we build AI agents?" to "Where should they run? Who controls them? And how do we deploy them responsibly?" Fara-7B provides one answer to those questions, an answer focused on local execution, user control, and practical efficiency. For those interested in exploring this technology, the resources are available. The model is on Hugging Face, documentation is on Microsoft Research, and the Magentic-UI interface provides a practical testing environment. Microsoft is actively seeking community engagement to refine and improve the system. The release of Fara-7B demonstrates that the future of AI agents isn't necessarily about who has the largest model. It's about who can deploy capable agents where they're most useful, respecting privacy constraints and operational requirements. That's a future worth watching closely. If you found this analysis valuable, consider engaging with the content and staying informed about developments in agentic AI. The field is moving quickly, and understanding these architectural choices will become increasingly important for anyone working with or building on AI systems.